All right, so on the front side of this page, on this lesson, we're going to talk about percents. What we remember, maybe add a little bit, maybe think about them in a different way. And on the back side, we're going to say why we're doing this. We're going to bring them into the exponential functions discussion. Okay? So we'll start with the front. And I know this is one of those lessons where you can maybe get a little ahead, but I'm going to add stuff that's not on the page, so just try to stay with us as you go. Okay? Okay, so write the following as decimals. What's the rule for turning a percent into a decimal? What's the trick? What can you do every time? Yeah. Move the decimal point 2. So if you don't know that, write that. Move decimal 2 to the left. Okay, great. Wait, there's no decimal.
It's right behind it.
Yep, there's an invisible decimal right after any number, right? So if you take that and you go boom, boom, it ends up right here, and 48% becomes 0.48, right? Now, great, okay, here's my decimal. If I move it, I can only move it once.
Twice.
Oh, if I move it again, now I have an empty spot, so 0. Now, then I'm glad that seems like you've seen that before. I can't tell you how many times. I've seen 7% turned into 0.7, which is 70%, and very different. Okay? So 7 becomes 0.07. Here I already have a decimal. Great. I don't have to imagine where it is. Same deal. Moves twice.
So it's 0.125.
Yeah, and sometimes you end up with 3 numbers after the decimal, and that's okay. Okay, that'll happen sometimes. All right, last one.
1.2.
Boom, boom. Yep, and sometimes you end up with numbers on both sides of the decimal, and that's okay too. 125%, that's more than 100%, right? So it makes sense that our number is more than 1. Right? That would make sense. Okay, now let's talk about these AirPods. All right, see the AirPods, they are normally $299, right? But it says they are on sale for 30% off, meaning down. What's the new sale price? Notice what I'm doing. I like to circle my numbers and then underline key pieces. I just start coding right away. It helps me decode word problems, right? So then when I didn't really know the question yet, and I knew I'd need that, I knew I'd need that. Off means down, right? I just kind of start coding. So I'm going to do that the whole lesson. All right. Anybody able to do this? Yeah. Okay. Go ahead, Fatima. Talk me through it. Yeah.
30% of 299 is...
Hold on. Talk to me how you did it. 299
0.30
times 0.30?
Yeah, and I got 89.7, and then I...
Oh, slow down. I can't write that fast. So how did you know 0.30? Because you moved the decimal twice. Okay, and then you knew to multiply. Okay, and then you got what? 89.7? Okay, so that's 30% of 299. Hold on. And you subtract it. Okay, so then you had 299 minus 89.7, and you got 209 and how much? 30 cents. Beautiful. So that is the new price. Correct? Awesome. Yeah, question?
I got a different way.
Oh, great. Let me hear about it.
You just take 100 and then subtract the percent thing, and the thing we have 30 here. We do 100 minus 30, and it's gonna be 70, 0.70. Then you multiply it by the number, and it's gonna be the answer. You don't have the subtraction.
That is 100% correct. So think about what you just said. I'm gonna try to rephrase it in a way that I think will be helpful for people. When we have something, how much do we start out with? 100%. How much did they take off this item? 30%. So how much will be left? So if we're asking ourselves what the new price is, the new price will be what percent of the original? 70%. So we can just skip to finding that, right? Just say, it sounds like we want to know what 70% of the original price is, right? So instead of multiplying by 0.3 and then subtracting that, we multiply by 0.7. So let's see what happens when we do that. 0.7, 299 times 0.7, what do you get? 209.3. And this is the way I want you to be thinking today. This is fine. This is accurate. That's more efficient. It gets right to the answer. Like, this is extra steps you don't need if you know how to do it the other way, right? This 0.7, we got that by going, okay, 100% minus 30%, right? That gives us 0.7%. That's what we're looking for. That's what our end goal is. We want to know what 70% of the original price was. Make sense? Okay. We'll do like 4 of these so you can really kind of lock this in. I'll go through the first one with you, and then I'll ask you to do the other 3 on your own. All right, so here's an example of your thought process, right? This one will take you through in steps. Eventually, I hope that you do all this on your own. Okay, so you got a sweater. It's $80. It's been discounted 25%. Discount means to go what? Down. And 25% is 0.25. I don't know if we'll need that, but I just like to code. Okay, what percent will the new price be of the original? 75%. How did you get that? 75% is correct.
Wait, this was part of the one subtract?
No, we're moving on now.
Okay.
You took what?
100%.
You have 100%, and you know that it's discounted 25%. So our percentage of the original left will be 75%. Okay, great. Write that as a decimal. 0.75. And we want to know the new price. So how do we calculate it? 80 times 0.75 equals $60. We get right to our new price, right? Remember, the alternative was to do, okay, 25%, then we subtract that, then we get our answer. We just jump right to our answer, okay? All right, go ahead and try these other 3. I'll give you a minute or so, and then I will go over them, and we will move to the back side where we're in exponential equations, okay? All right, we ready to talk about this? Ready? Now, here we go. Original price of a book is $90.50. That's expensive. Hey, when you get to college, that would be cheap for a textbook. All right, so now we get 9% tax, which is 0.09 if we ever have to make it a decimal. I don't know. Now, tax, does that make your price go up or down? Yeah. Like, when you pay tax, I don't pay less than I thought I was going to pay. I end up paying more than I thought I was going to pay. So what percent of the new price will be the original? Well, we start with 100, and we're going up 9%, which will be 109%. It's okay. So that as a decimal is 1.09. So the new price will be 90.50 times 1.09, which is 98.65. And there's a sense check, which some of you did. One of you said, hey, I thought with tax it goes up. Why did it go down? You were actually figuring out that you did something wrong there, because that didn't make any sense, right?
Negative instead of plus.
Yes, exactly. So that's good. That means you sense check your work and you go back and you make sure it makes sense, right? That's a good thing to do, right? So yes, if you went down, you'd be like, something went wrong here. Tax is supposed to make things go up, and that's fine, right?
But wouldn't investment? I'm going ahead of myself.
Yes, investments totally different than taxes. No, this is everybody's brain gets tripped up on similar things. That's why we have the problems. All right, original price of a concert ticket is $120. It gets discounted, which means down 21%. That's 0.21. What percent of the new price will be the original? Well, 100%, but it's going down, so we subtract 21%, so we get 79%, which as a decimal is 0.79. So then we say, okay, 120 times 0.79 to get our new price, which is 94.80. And I sense check. I'm like, well, it was discounted by about 20%. That seems about right, right? Went down a lot. Good. All right. Cade bought some sneakers for $775. Now he wants to resell them and make 30% on his investment. So he's going to want more than $775. What's that? Well, he's multiplying to get his answer, but he's going up by a percent, right? So think about it. He has 100% right now. How much does he want to make? He wants 30%. So he adds 30% to that, and he needs to sell it for 130% of what he got it for in order to net that 30%. Okay? So we write this as a decimal as 1.3. And then 775 times 1.3 is? Good luck, Cade. Although, some of y'all in your sneakers, man, maybe somebody will buy it. All right, so why do we just spend so much time in percents? Because they have to do with exponential equations, and we're a little behind here, so I'm going to go a little quickly here. Now, sometimes in exponential equations, well, think about exponential equations, right? You have y equals ab to the x. But when you're given a situation, it's usually not like, hey, there's a population, it's growing by timesing by this every year. Usually somebody says it's growing by 5% or something. It gives you a percent. You have to figure out what to multiply by. And that's what this part is about, right? How do we get from the percent to our multiplier? How do we go from a percent to our b, right? So we need to talk about that, right? So let's talk about what we know already. Let's talk about where we're going. Okay, we know y equals ab to the x, where a is our start and b is our multiplier, right? But what if somebody says, hey, it's growing by a percent? It doesn't tell you what to multiply by. You need to figure it out. You need a formula. And that formula says b equals 1 plus or minus r, where r is the percent. R equals the percent increase or decrease. And that will tell you whether it's plus or minus. Now, so R is your percent increase or decrease. What does the 1 represent? 100%, right? Think about what we did on the last page. We had up by 30%, so we did 1 plus 0.3, which is 1.3, right? This is just skipping right to it, okay? All right, so because of that, our formula becomes, instead of y equals ab to the x, it's y equals a times, what do we replace b with? 1 plus or minus r to the x. Okay? So we find our b by using our percentage. Okay? So we'll go over some examples, we'll talk about some zombies, and then we'll be done. Zombies? What is he talking about? Okay. So here we go. A car has an original price of $1,600, sorry. It will drop, meaning go down, by 15% over the next year. And I'm just going to go ahead and turn that into a decimal right now because I probably will have to. Now, does this increase or decrease? Decrease. So at this moment, you ask yourself, okay, will B be 1 plus R or 1 minus R? Because it can't be both. Minus. 1 minus R. For us, that means 1 minus 0.15 or 0.85. So if we were to write an equation here, we'd say, okay, y equals 16,000 times 0.85 to the x. And that should make some intuitive sense to you. If you're going down 15% a year, well then you would, first year, you'd multiply by 0.85. You'd find 85%. And then another year goes by, and you take that number and you multiply by 0.85 again, and then 0.85 again. And the repeated thing you do is you just keep multiplying by 0.85 x times. X is the number of years. Okay? Next one, a meal comes to $32. Additional tip, so we're going up, of 20%, which is 0.2. Is it increase or decrease? Increase, so we're going to go 1 plus R, or 1 plus 0.2, which is 1.2. So our B is 1.2. Our starting point is 32. Okay? All right, next one. You got a population of bacteria. And there are 500 of them. It starts out, so that's your starting point. The population is decreasing. It tells you, real nice with them, by 7%, which is what as an R? 0.07. Okay, each hour. Okay, so increase or decrease? Well, it said decrease. So we're going to go 1 minus R, or 1 minus 0.07. So our B is what? 0.93. And let's go all the way to the equation this time. Y equals 500, our starting point, times 0.93 to the x. X represents the number of hours, right? Now it says how many bacteria cells we left after 5 hours. What do? Plug in 5. So I would say, okay, y equals 500 times 0.93 to the 5, and I get 347.8, which would have to, yes, exactly. Can you explain why? You can't. When you were talking about living things, you would say, there's a couple, give me a second. There's a couple different ways to think about this. You could just round to the nearest one. I'd be fine with that. My thing is, well, if it's decreasing, right, and this, let's say it's killing them, right, and then it gets down to 347.8, well, then there are 347 whole ones left. So I wouldn't round up. I'd round down. Yes, but that's not, we wouldn't count them. So, but I've heard other people who interpret it a different way, and they'd say, well, actually, it's 348 because that's fine. One of the two. I won't take off for rounding there. We'll let a biologist decide on that one. But yes, you would have to round to an even number. You would not have half of bacteria. A living thing can't be a half a thing. Okay, last thing, zombies. Okay, so here's the situation. And I'll hand out your homework while you work on this. You got these zombies. They're growing at 9% each day. First of all, what's the percent increase each day? Then what's the percent of any day compared to the day before it? Yeah, think about it for a second. If the population was recorded originally at 6 zombies, write an equation to represent the growth. And what if the population instead decreased by 9%? What would be the new B value and the new equation? And I'm going to add some pieces here. Ready? Let's make this fun. Okay, for C, I'm going to say how many after 200 days. And for D, I'm going to say start at 100,000 and how many after 122 days. Okay? A little extra for you to do there. Okay. Let me hand out your homework while you work. All right, let's go over the answers real quick. Ready? Okay, so what's the percent of increase each day? 9%. So that means what percent of what is the percent of any day compared to the day before it? 109%. So compared to yesterday, there are 109% zombies out there, right? That's what you would say. Okay? So if the population was originally at 6 zombies, well, we got our B. Our B will be 1.09, right? And our starting is 6, so it's y equals 6 times 1.09 to the x. Now I asked about 200 days. Where does that go in? Yep, x equals 200, and then y becomes what?
1, 8, 3, 4, 2, 1, 7, 5, 2.
Yep, there's a lot of zombies, 183 million of them. We got problems.
Billion or million? Wait. Somebody
All right, now let's say it was decreasing. Well, our b is 1 minus r, right? Our r is 0.09. So our b equals 1 minus 0.09. Our b is 0.91, right? Okay, so now y equals, and we said our new start value was 100,000. So 100,000 times 0.91 to the x. And then I gave you an x value of 122. So you just plug that in, and you get
0.000060423.
Anybody get a different number?
Oh wait, I did 6. Okay.
It's approximately 1 zombie left. Yeah. 1 zombie left. We did it. We beat them.
Wait, isn't it that?
All right, so go ahead and put the warm-up to the side. For a second, we're going to talk about the homework. So have your homework out. We'll kind of hit each section, see if there are questions, talk about the skills, and then we'll move back to the lesson. Okay, so for your homework, we're dealing with those exponential functions, which of course we talked about is y equals ab to the x, where a is your start, b is your multiplier, and so on and so forth from there. Okay? And there's things you need to do. First thing you needed to do was evaluate. Evaluate, of course, means find the value, plug in, do the math, right? So for each of these, it was like, okay, here's your function, something to the x, and then here's your x, plug it in, right? That's all you had to do. So you put the 3 in the exponent spot here, put that in your calculator, get your answer. Any questions on any of these?
What is 4 decimal? What is 4 decimal? I thought it's like round up. Like
It says 4 decimal places, 1, 2, 3, 4. So I guess this was 0.00, so I didn't write it. I don't know. But yeah, 4 decimal places, if necessary. Okay. Next section, we were talking about growth or decay. Now remember, we talked about the rules here. If your b is greater than 1, you have growth. If your b is between 0 and 1, so a decimal fraction that's less than 1, you have decay. So for the first three, it's like, oh, I can see the B spot. It's this right here, this right here, this right here. It's the thing being raised to the x, right? So less than 1, decay. Greater than 1, growth. Greater than 1, growth. The next one's maybe not as clear because you had to do a little math, right? So you would say, okay, what's being raised to the x? This whole thing, right, is being raised to the x. So that's your B. So you ask yourself, what is that whole thing? Is that whole thing less than 1 or greater than 1? Well, it's 1 minus something, right? So it's less than 1, right? Decay. This one is 1 plus something.
So it's going to
Yeah, even though it's very small, 1.001, right? It's still greater than 1. It's still going to grow very slowly. And this is 1 minus something. So it would go down. It would be decay, right?
So would the rule be for those kind of equations is if it has a minus, it would be decay. If it had a 0 plus, it would be growth.
Yes, for the most part, unless you were minus minus.
Yeah, unless you were minus.
Yeah, yep. All right, your next section was kind of like our lesson yesterday. You had patterns. You had to identify the pattern, extend the pattern, define the pattern. And that's, you define it through an equation, right? So you had to do those three things. And when you did that identify and extend thing, you have to kind of recognize what type of pattern it is, right? So for instance, this is multiplying by 1/2 every time because it's going down by 1/2 every time, right? So this is times 1/2. So that's multiplying, so that's exponential. This is multiplying by 3 every time. So that's exponential. This is adding 7 every time. So that's linear. Different patterns have different functions that and different forms that you go into, right? These two would be y equals ab to the x. But this one is y equals mx plus b, right? So here I'm looking for a and b. Here I'm looking for m and b, and a different b, right? So that would change. Any questions on how to do one of these?
For part A,
Mm-hmm.
I did 1/2, but I did it as a decimal.
Okay. Yeah, that's fine. Decimal is fine. Anybody struggle finding the multiplier here? Okay. So look here, right? So let's say we were doing this one first, right? Well, you would say, how do I get from 5 to 15? And you would say, oh, I would multiply by 3. So basically, the question you asked yourself in your head is 5 times what equals 15? And you said, oh, I know that. It's 3, right? But let's say you got that far and you couldn't figure it out. Well, that's where we're over here, right? Let's say you have like 72 times something, some blank, equals 36, right? You know there's some multiplier out there, you just don't know what it is. So this is your thought process, right? And you're like, how do I continue here? Well, when we have a missing thing in math, an unknown value, what do? Make an x. So instead of something, I think of it as x. If I had to find that x, what would I do to solve? Divide by 72. Divide by 72. So x equals 36 divided by 72. Right? 36 divided by 72, you could reduce that. You could put it in your calculator, get a decimal. Either way, you would get to this number of 1/2. And you'd be like, oh, it must be multiplying by 1/2. And you could test it. You could go 36 times 1/2, 18 times 1/2, 9 times 1/2, and you'd always get that next term. Okay? So it's just a way to back into that number, especially when it's going down. That's a useful tool to use. Make sense? Okay. On to the back. So on the back, there are 2 different pieces here. You had a graph that you needed to turn into an equation, and then you had equations you had to turn into a graph. Really the same problem, but forwards and backwards. And in either case, I recommend an XY table. Okay? Either, anybody have a preference on 4 or 5?
4, 5.
5. Okay. Now, what makes 5 tricky is it's what? Decay, right? Growth just seems a little more straightforward, right? But if we make our xy table, xy, okay, it's like, okay, what goes into that xy table? That's a little too big. I don't need that big of an xy table. Well, points go into an xy table. Where do we find points? On the graph. I would start on the y-axis because there's usually a really good point right there. All right? Then I would go to the right and to the left of it and see if I can find more good points. So if I look into the right, well, I go 1 over, there's another good point. I go 1 over, there's another good point. What do I mean by good point? Exact. And we know it's exact because it crosses right where the squares are, right? Where the square meets, right? In other words, if I go over 1 more, that's not a good point. I could probably guess what that is, but I don't know for sure. So I'm going to leave it alone. I don't need every point. I just need some points. If I went backwards, I found more good points. There's one right there. And yeah, there's one right here, right? So I have plenty of points. I don't need any more probably. Okay? Now, I throw these into the table. And let's see, I had -2, 16, -1, 8, 0, 4, 1, 2, 2, 1. Now, at this point, it becomes just like the problems on the front, right? I have a table now. I don't even need to look at the graph anymore, right? I can just say, okay, I know I need y equals mx plus b. I'm not mx plus b, ab to the x. And I need to find my a, I need to find my b, right? My a is my starting point, my b is my multiplier. My starting point is always my what? Where x is 0, right? It's my y-intercept, so it's 4. My b is my multiplier. Well, we just had a problem where we were like, how do you find the multiplier where it's going down? And what did I say to do? Yeah?
I don't remember what you said, but what I do is I take one point, and then I take the next point to the right, and then divide the first point by 2.
That's exactly what I said to do, but you're just talking about it in a different way. You just do it in your head. You just say, I'm going to divide that by that. What I did was I set up an equation which did the same thing, right? I said, well, I know that 4 times something equals 2, right? We need to know what that something is, so we make it into x. We solve by dividing by 4, divide by 4, and I get 2 divided by 4. Well, that's exactly what you just said to do. Take a number, divide by the previous one, right? It's the same process. We just have different ways of thinking about it. 2 over 4 reduces to 1/2, so that's my b, okay? So my b is 1/2. I have my pieces now, so I say y equals 4 times 1/2 to the x, okay? All right? Now, the last type of problem were these graphs, right? Same type of thing, and this is the answer key, so yours were blank, right? But same type of thing. I would need to make a table, right? It's going to help me get my points that I need. So, do we have a preference on which one we want to go over? 6? 6 and 8.
9. Oh,
Okay.
wait, we're not 9 yet.
I think we're going to do 6 and 8. Okay. So 6, x, y. Okay, I know that y equals ab to the x. So what's my a here?
48.
Right? That's my a. And what's my b?
1 over 4.
Right? This is my starting point. That's my multiplier. So if I'm trying to find points, right? Well, -1, 0, 1, 2, 3, something like that. Okay, that seems to be what they're offering up here, right? You might be like, how do I know that? I don't know. I just picked what I see that is available, right? It seems to start here and go to here. So if I need to expand it, I'll expand it at a later date. But I'm not going to start with -1. What am I going to start with? 0, because I know the value there. It's 48. I multiply from there. What what happens when I multiply 48 by my multiplier 1/4? It's like dividing by 4, right? So that's 12. And then I multiply that by 1/4, which is like dividing by 4, so that's 3. And then I do it again, I get 3 over 4, or 0.75. If I wanted to go backwards, I multiply by 4.
By 4? Yeah, by 4.
Yeah, because it's dividing by 4. So instead of going down by dividing by 4, I would multiply up by 4.
182? 92. Yeah, 192.
192. Sounds right. Yeah. All right, so that's not going to end up on our graph. It's a little too high. So we'll start with 0.48. Then we'll do 112, 2, 3, and then 3 3/4. So we're getting so close to 0 that we have enough points. And we're good. Okay? Yeah? Okay. All right, this one, I will say I think the answer key is wrong here. Okay, so this one. Now, remember our form. It's y equals ab to the x, but I have y equals 3 to the x. What's missing? My a. Something's being raised to the x, so my b is good. I'm missing my a. When something's missing, 0 would make everything go away. It's 1.
Okay.
So I have y equals 1 times 3 to the x. Now I have everything I need, right?
Then that wouldn't. Wait, would that still be a curve?
It would.
Yeah, think about it. If I made my xy table, well, we'll go -1, 0, 1, 2, 3. Okay? So what point do we start with? We usually just steal our what? Our a value, which is 1.
1. Oh.
Right? That's our a. And then I multiply by 3, and I get 3. And I multiply by 3, and I get, and I multiply by 3, and I get, and this is where the answer key is wrong. If I went backwards, I would divide, and I get 1/3, right? -1, 1/3, and then I'd have 0, 1, 1, 3, 2, 27. So the answer key was wrong there.
2, 9.
Oh, sorry, 2, 9. I'm wrong. 2, 9, 3, 27. I got ahead of myself. It was wrong. I was remembering it from another class, and I just got excited at how wrong I was. Okay, so 2, 9, 3, 27. I like being wrong. It shows you I'm we all make mistakes, right? So 220, and then we go from there. Okay, so there's your graph. So if you're ever missing your A is 1. Okay, we ready to go to the lesson? Okay. All right, let's talk about percents for some reason.